little bit of party, never get nobody. Come let's move our body.
Hey guys, my name is Alex, otherwise known as ACATS on social media and Discord. Today I wanted to walk you through this new Audioreactive Dancers workflow that I put together in collaboration with Syncratic. I will put his link to his socials in the description below. But basically I just wanted to give you an overview of how to use the workflow, how it works, and show you how you can make some pretty cool things with it. So let's just dive right in. You'll see an overview of the whole workflow right here. And I know it looks very complicated and there are a lot of moving parts to it, but the actual amount of things you need to tweak or adjust when you're first getting started is relatively small. Alright, so if you just want to get up and running with this workflow as quickly as possible and start creating some cool videos very fast, then there's a few sections you should pay attention to. The first is the input section, then the prompt, then the model section, and then IP adapters. As long as you adjust the settings here, make sure it works out to the video that you're trying to create, then the rest of the workflow should be relatively automated. So let's start by checking out our input section here. So first you have settings for your output width and height. Right now it's at 512 by 896, which should be a good, vertical video format for social media like TikTok. Then you have your frame skip, so how many frames of the video, whether to use every frame or every other frame. If I set it to 2, for example, most of the time I just leave this at 1. Skip frames, so this is how many frames to skip from the beginning of the video. So right now it's at 0, so it's going to start at the very beginning of the video, but you can increase this to, for example, 100, and that means it will skip the first 100 frames of the video. And this is really useful if you're trying to render a long video. You might want to split it into multiple batches. If you don't have enough VRAM, for example, you can do a couple renders of 200 frames versus just one render of 400 or more frames at one go. And then over here we have our frame load caps. This is how many frames of the input video we should load in total. So right now I'm loading just 60 frames, and so I recommend when you're starting you set this to a relatively lower number, around 30 or 60, just to make sure all of your masks and everything looks good, and then you can bump this up when you're trying to actually render the final video. Then you have your load video node. This is where your input video is going to go for your subject and for audio. Over here we have our seed, and then over here you have some debug information about the input video. So this is how many frames you're currently using. This is the total number of frames your source video has, the source video width, source video height, and the source video frames per second. So just some useful info there. Over here you have a section to set your own mask for the subject. So if I want, I can unbypass or unmute this group and then upload a mask for my dancer, and then this will essentially override what we're trying to auto-generate in our segment dancer group over here. So in this case I just want to use the actual segmentation model, so I'm going to mute this. And if you take a look here, this should basically just work automatically. It will segment a mask for your dancer. As long as you get a good mask here, you don't need to adjust any settings, but later in the video I'll explain how you can tweak the prompt here a little bit in case you don't get a perfect mask on the first go. Moving on, you have your prompt. So this is basically where you're going to set your positive prompt and your negative prompt. This is a batch prompt, so if you want to specify different parts of the video to use a different prompt, you can use the format frame and then your text to describe what you want the scene to look like. And so here I could say at frame 10 I want it to look different. I can have something whatever you want, and you can just specify different breakpoints where you want the prompt to change over time. For the most part, since I'm using IP adapters in this workflow, I just set one master prompt, and this will be used for the entire length of the video. Down here you have your model section, so this is where you set your VAE, and then you have this model merge stack. So this is useful when you want to merge different styles of models together. So for example, if you have one model that's really good at animation and you have one model that's really good at realism, you can sort of mix and match the weights of the two models to get a better final output than just one or the other. So in this case, I'm using the Paradigm LCM model, which I find is really good at animation, and I'm mixing that with some weights from this Absolute Reality LCM model, which is really good for realistic videos. So you can play with the weights, you can play with the model merges. Down here you have your LoRa stack, so you can set one or more LoRas if you have a specific character or style that you're trying to execute in your output. So for now, I just have the Animate LCM T2V LoRa at a low weight of 0.18, and this just helps to improve the consistency of the final animation. And then we have our Animate Diff section. You can mostly leave this alone unless you have a specific motion LoRa you want to use for your Animate Diff settings. In this case, I'm using Liquid AF, which I find adds a really nice kind of smoothing motion to the final video. And then you have your IP adapter section. So this is where you're going to upload all of your reference images for how you want all the different masks to look. So for example, here we have our red, green, and blue IP adapters. And so you can upload reference images for each of those subjects. So in this case, my subject is going to be red. So I will upload a reference image to transform the look of the red subject in the video. Then black represents the background of the video, so you can set a reference image for that. White will be the Audioreactive Dilation mask, so if you choose to enable that, you can set your reference image for that here. And then your yellow and magenta IP adapters will be used to set the reference image for those masks, which we're going to be creating using those Voronoi noise generators that I will explain later in the video. So if you're curious as to what that looks like, if we come up to our composited final masks over here, you'll see I have my red subject dancer mask here, surrounded by this white Audioreactive Dilation mask. And in the background we have yellow and purple noise shapes, and these are also Audioreactive. So just keep in mind that these are the masks that you are choosing to have these IP adapters reference in this section here. Just make sure that you fill out all the images. I recommend you bypass the K-sampler when you're first testing out the workflow, just to make sure all the masks are generated. And then once you have a good result, you go ahead and unmute that, unbypass it, do a test render, choose 30 to 60 frames using frame load cap. Just make sure it looks the way you want it to, that you have all your IP adapters set the way you want it to. And then once you're ready, you can go ahead and run a full render with a higher frame load cap. And you can also unmute the high-res fix group, which will help to add details and upscale the final result. So if you're just trying to use this workflow, get quickly started with it, those are the settings, the main settings you have to adjust, and then you'll see all your outputs over here in this group over here. And you can go ahead and save them. You can change the directory that the output will be saved to. But yeah, so now I'm going to go into a more in-depth explanation for each of the sections, so you can get a better overall idea of how this workflow works and how you can potentially build sections of it yourself if you're learning Comfy UI. So yeah, let's move on to the next section. So now let's go up here and just see how we're doing this actual compositing. So first thing we need is to process our audio. So over here, we have a getter that's basically grabbing the audio from our input video, and then we're using this audio separation node, which is just grabbing the stems from that audio. So it's trying to grab the bass notes, the drums, if there's like synths, it'll probably put it in other, and any vocals. And so you can preview that, using these little preview tabs here. And this will, just set these setters, which we will use in these different processing groups here. So you can see right now for this workflow, I'm just processing the bass and the drums, which tends to capture, the beat of the song. So I found that drums tends to sometimes grab more of the bass than the actual bass stem. So this will, take some trial and error, preview the audio before you commit to making any of the masks, either use the drums or the bass, and just see which one seems to have a more regular beat or rhythm that you'd like the masks to react to. So for the bass section here, we're basically just grabbing, the signal, and you can see these graphs are set to show you what the amplitude looks like. So this is a normalized amplitude. So this first graph is just going to show you the amplitude of the signal for that particular stem. So in this case, this is the bass stem. And below this is what the cleaned up kind of gated amplitude will look like after we processed it. So essentially this signal is coming in through our stem, and we're just like normalizing it here. Then we're applying this amplitude gate to it that says, only give me signals that are above right now 0.8. So if you look at the original graph, we're saying anything above this line keep as signal, and everything below it just throw it away. And then finally we're passing it through this shrink number sequence node. And what this does is it just says if you have a number, so in this case 1, so you'll see as part of this amplitude graph, we'll have a bunch of values or a bunch of frames be 1.0, and then it'll drop down to 0. And so what this does is it's basically just shrinking the number of values in a row to 2 in this case. So you'll get more of a sharp peak instead of kind of like a long drawn out sequence of ones, which will make the mask look like it's kind of expanding and contracting instead of just expanding out for a set period of time and then contracting again. And that's what this graph shows here. So you can play around with the maximum occurrence here to get kind of different results. So just to demonstrate that, if I put 4, you'll see that it will basically grow the length of the number of numbers in the sequence, so you'll have longer periods of expansion. Cancel that. So this is the same thing, but just for the drums. If you want to have another stem be processed, you can copy, this section, paste it here, and then have that process by adjusting the input, the getter here to vocals, and then setting the correct setters if you'd like. That's optional. Over here we have our dilation mask. So this is where, if you want to, you can set the pulsating aura around your dancer. So in this case, we just have one mask, which is this white Audioreactive mask, and the end result will look similar to this. So, I have my red subject mask here, my dancer, and then we're just applying this pulsating white mask around them. And you can adjust some settings here. So you can set the maximum radius. This is how wide the mask will be when we're at an amplitude of 1. And our minimum radius is the minimum amount that the mask is allowed to be. So if you set this above 0, the dancer will always have some kind of aura or some kind of mask around them. And then we just basically do some compositing. Here we have an override section. So if you already have generated a composited mask video like this, you can use that and just upload it here into this load video node, and that will save you some processing time later on. Make sure that when you do decide to override it, you also mute the white Audioreactive mask section. And so this is basically just going to grab your video here, put it as the output, and then use that in the final render. So for now, I'll just leave this on. We go up here, we'll actually see our Voronoi noise generators. So basically this is what's creating all those intricate shapes that you see in the background of these videos. So moving left to right here, you have your inputs, so frames with height. Going left to right down here, you have your randomness scheduler. So if you want to break up some of the symmetry, I suggest playing around with these numbers, increase them from 0 to 1, 2, 3, and just see how it affects the result. There's like a lot of experimentation you can do here. I haven't fully explored it myself, so if you find a way to make some really dope effects, then definitely let me know. Post it in the Discord, share it. You also have your keyframe scheduler. I haven't really played around with that too much. Detail scheduler, so this is how detailed, how many points in the Voronoi noise you have. Try experimenting setting this to a really low number like 1 and a really high number like 100 or 200 and just see the difference in the result. Finally, one of the nodes that will affect the movement of the noise the most is this scale scheduler node. So right now the formula is set to gentle oscillation change, so this will basically adjust how the noise is affected over time. So this basically causes it to go out and then in and then out and then in, like very slowly, which is really good for audio reactive effects because you can sort of speed that up or slow it down later on. But definitely experiment with some of these formulas. So you've got sine, cosine, curves, logarithms. Just try different ones and then get an idea of how it affects the final result. The other thing that will affect the look of the noise a lot are these actual Voronoi generator nodes. So what you can do is you can adjust the distance metric. So in this case, I have it set to kaleidoscope and Euclidean, but you could set it to elliptical and kaleidoscope, and you'll get a completely different look, a different result. If you want to preview what that is going to look like, I suggest unbypassing this preview image, and then when you run it, you'll get a preview of what kind of shapes this noise is going to produce. So here you go, you can sort of see how it moves and also what kind of patterns you get after messing with your generator nodes and also your scale scheduler. So we have the same thing for a second generator. So the first one here is used for your bass or your drums, and then the second one is also bass or drums, depending on which one you want for you can change it depending on which noise patterns you want for which audio. So moving on to here, so here's the section where we're actually taking that Voronoi noise, turning it into a mask, and making it speed up and speed down based on the amplitude of that stem. So when the amplitude is high, so we're on a beat, it's at 1, we want the noise to basically speed up so it looks like it's moving quickly. And then when the amplitude is close to 0, we want it to slow down so it looks like it's just kind of moving gradually. These nodes here basically adjust the pattern of how it moves so it doesn't just go fast and then slow in a really, really rigid pattern. It actually will sort of speed up and then slowly slow down, so it's more of a natural looking effect. And the way that I achieve that is using this lag chop node that I was inspired to create after playing with Touch Designer for a while. So basically, if you lower this value, then you will get more lag on the peaks. So what that means is the noise will speed up quickly and then it will take longer to slow down. And if you increase this to a higher number, then you'll get kind of a spikier result. So it'll speed up and then it'll slow down really quickly. So you can get an idea of how that looks here. So see, it kind of looks like it's really jumpy because it will speed up and then slow down really quickly. Whereas if I lower this to, let's say, 35 and try again, you'll see how it kind of speeds up, but then it stays fast for longer before it slows back down. So definitely play around with the lag chop settings. I like to keep it around 50 for the most part. And then moving down, we have this rescale float list. So this basically is the range for how quickly and how slowly the noise pattern will move. So I set the minimum to 0.5, which means move half as fast as it normally would if I just let it run at normal speed. And the max is 20, which means run at, 20 times the speed that it would normally play at if I was just playing it as like a regular video. So you get an example of what that looks like over here with, the amplitude on the y-axis and your frames on the x-axis. And pretty much the only other node I would play with here is the keyframe scheduler. So what this is it's basically adjusting the cutoff for where you're taking the noise and turning it into a mask. So if I lower this, it's basically lowering the threshold for the brightness values for where I'm taking, my actual mask from the noise. And if I increase it, it's increasing the threshold. So it will use less of the noise. So you'll get kind of a more minimalistic effect like that. So definitely play with this because this will also greatly affect the look of the pattern and the final composite result. So over here you have the same nodes except for the bass stem. So the noise over here in the magenta will be affected by the amplitude of your bass, and the yellow will be affected by the amplitude of the drums. So if you want more shapes on the bass, play with this side, and then also, for the drums, this one as well. Finally, once we're done playing with our noise generators, we'll come over here to the composite mask section. We'll take in all of the masks, composite them on top of each other, like so, using a destination at top, and then an overlay. We're using the overlay to take our Audioreactive Dancer mask and subject and paste them on top of this mask group that we've created. So, play around with this. Make sure your sampler is bypassed when you're adjusting the masks, because you want to really nail down the look of your Audioreactive masks before you start rendering a bunch of videos. Once you're happy with the way that looks, the way that it reacts, then go ahead, unbypass this, do some tests, try out different IP adapters, see what looks good. I find that using a darker background image and a brighter image for your Audioreactive noise masks will give a better contrast, so you get more, visible, interesting results that way. But, again, this is going to take a lot of experimentation to find good images, and, so just play around with it, try it out. Down here, you also have your control nets. So this is pretty standard. You have your AD control net, line art control net, QR code, depth, open pose, and essentially you don't have to adjust these settings unless, there's something in the output you don't like. Right now I have the depth control net set very high, and what this does is it's basically going to do that kind of projection mapping. So if you have a background in your subject dancer video, depth is going to take the noise masks and make it look like it's projected against the walls and like the floor. So you can sort of see that here. You can see like the crease, where in the real input video there's like an actual wall here in the background and there's a floor here. So it looks like the mask is sort of like curving up against the wall, which I think looks cool. You can adjust it if you want. Down here we have our generator functions or preprocessors. So based on your input video, this will automatically crop and output your pre-processed depth, open pose, and our line art for our composited masks. So you can just leave this if you want, or if you have pre-generated your depth video, pre-processed depth video or open pose video, you can actually go ahead and bypass these groups and then unbypass the upload groups over here, upload the videos for the respective categories, and then when you run this, it will pull from these upload groups instead of the generation groups. So if you don't want to regenerate, your depth and your open pose videos every time you run the workflow, then I would recommend, first generating, pre-processing out your whole depth video, and then putting it into the upload, and it'll just save you time later on. So that's the workflow. Hopefully you guys got something out of this. Hopefully you can use the workflow, go make something cool with it. I will be posting the entire workflow to my Patreon page, initially in early access. So for 1 week, if you're an early access member, you have full access to the workflow. You can download the file. Otherwise, if you're a free member, you can wait 1 week, and then I will be posting the workflow for free for everybody. So yeah, let me know what you guys thought of this video. Hopefully it helps, and I will see you in the next one.